Hello there, everyone. Today we're going to be taking a look at how area model for division works. It's very similar to our area model for multiplication, in which we are going to be finding partial products. However, the process of getting ourselves there is slightly different. So I like to take a look at this and give ourselves a scenario, okay? So imagine that you're at a school and you're the librarian and you get a delivery of 989 books, and your task is to distribute those to 6 teachers, which ultimately will end up being 989 divided by 6. 989 books to 6 teachers, okay? And sure, you could do it one by one and hand each teacher the books one at a time, but it's going to take you absolutely forever. And so you kind of want to figure out how could you chunk this in a way that's easy for the teachers to maybe carry and bring back from the library, or that's easy for you to deliver. You might not have a super large cart. You kind of want to figure out what is the best way for you to be able to deliver this. So I'm going to come into here and I'm going to go ahead, just like we do with anything, we're going to go ahead and set up our box. The difference between our other area models is we're only going to start with one box, okay? We're going to bring our books into here. We're going to say, okay, my 989 books is going to go inside of here. And this is the box that it came in. And then over here on the left, we have our 6 representing our 6 teachers, okay? From here, I want to look at my 6 and I want to look at my 989 and I want to think, how could I get the closest to that 900 with multiplication to start getting some of these books handed out? I could give every teacher 10 books at a time, and that would work, but it's not going to get me very large because 6 times 10 is only 60. I could try giving 50 books at a time. I think that'd be reasonable for teachers to be able to carry. You know, they're the little scholastic, super thin ones maybe. So we can say we're going to go ahead and give each teacher 50 books for this first batch, okay? 50 books. So I have 6 teachers, each one's going to get 50 books, so I'm going to have to multiply. 6 times 5 is 30, and I bring my 0. That means I will have distributed 300 total books so far. And so since I took 300 books out of my box, I need to represent that using subtraction. So I subtract, and I am left with 689 books left. I still have books I need to hand out. This box, through the process, got a little damaged or something, so we're going to go ahead and we're going to make ourselves a new box, and we're going to bring that 689 over, and that's how many books we have left, okay? So I'm going to ask myself, well, I did 50 the first time. Could I do 50 books again? And I look at it, and 50 is 300, and I say, yeah, I could easily do that again. But you know what? I'm running out of time. I need to get these done by the end of the day. And so I'm going to think about, how can I do this faster? Is there a more efficient way for me to be able to do this? And I look at this, and I say, well, okay, if 50 books was 300, I want to try and double that. That would be 100 books, and 6 times 100 is 600. I can do that. I have 689. So I'm going to come over here and I'm going to write 100. I'm going to skip right in the books for space sake here. But 689, that was 600 books we're going to distribute now. Now we can subtract that, and I am left with a total of 89 books left in my box. So far I've distributed 150 sets of books, or in total I have distributed 900 books to all the teachers. I have 89 left. I'm going to go ahead, make myself another box and bring over my 89. And again, I got to think, how many books could I distribute this time to see how close can I get? This is where knowing my 6 facts will come in handy. I think a 6 times 11, that's 66. 6 times 12 is 72. I only know up to my 12, so I'm going to go ahead and I'm going to say 12. 6 times 12, that's 72. So we give each teacher 12 more books, and we subtract that, and we end up with 17 books remaining. Again, we make ourselves another box, we bring that over, and I say, okay, how can I get to 17? Well, 6 times 3 is 18, and we can't go over. So we can't do 6 times 3, so we're going to have to go to the step below that. So that's 6 times 2, which is going to give me 12, and that was 2. And we subtract, and I get 5. which means that we have 5 books left over. The teachers are going to have to figure out how they want to share those because there's 6 of them and there's only 5 books remaining. So someone's not going to get a book. Maybe they'll rotate these last 5 through the classes or something. But so far we have taken our books and we have distributed them. Our final step is to take our total numbers up here and add them together to find out how many books is each teacher going to get. So I look at this and I say, okay, I have 100, I have 50, I have 12, and I have 2. And if we go ahead and try and add that together with barely any room left over here, we get a 4, we get a 6, and we get a 1. So in order to distribute our 989 books to 6 teachers, each teacher is going to end up with 164 books with 5 books left over, okay? That is a remainder. 164 books per teacher with 5 books left over. And we represent that in 2 ways. We say 164 R5, remainder of 5, or we say 164 and 5/6, whatever our divisor is, and our remainder, 5/6, okay? We almost had a full set to be distributed. So that's area model of division. We like area model of division because it allows students to just jump in and immediately do the math. Other methods like standard algorithm or box method really require the students to know their multiplication facts to get to the highest dividend that they can. Whereas this, I was able to just jump in. I thought, you know what, 50 books, let's jump in and go 50 books. Yes, if you don't know your multiplication, it's going to require you to do more steps. Ultimately, you're going to end up with more subtraction steps, but it allows students to jump in where they know, meet them where they at. If they only know 6 times 10, they can distribute 10 books at a time to each of these teachers. It's going to take them a while to be able to get to this final step here and see that they have a remainder of 5 because they're only doing 60 at a time essentially. But it is a valid strategy and it does work. So it allows students to figure out what makes sense the most for them. So that's why we like using area model, because it breaks it down for the students and meets them where they are. Let's see how that would look with another problem without writing books and teachers on there. Let's go through a full problem together. All right, so let's say that we have 737 divided by 4. And if we wanted to look at it the same way, it's 737 books distributed to 4 different teachers. It's good to mentally be able to do that and draw a picture in your mind of what you're doing to help connect things to things that we've learned in the past. But we have 737 divided by 4. One of the first steps that I'm going to encourage students to do is take a look at our divisor here and write down some of the most common facts of that, the friendly facts. For example, we're going to go ahead and we're going to write 4 times 10 equals 40, but 4 times 100 equals 400. We can do 4 times 5 equals 20. 4 times 50 equals 200. We can say, I don't even know, we can say 4 times 2 equals 8. 4 times 20 equals 80. We could even say 4 times 200 equals 800. I encourage the students to write down a list of some of these common facts. It just helps them get a jumping point into where they need to be to solve the problem. So the first step should be to write down these facts. And I recognize now that it's cut off on the side here. But yeah, 8, 80, and 800. So what we can do is go ahead, just like we did before, we're going to go ahead and set up. We're going to draw ourselves a nice little box. We're going to bring our divisor down, and we're going to write our dividend inside, 737. And I need to look at my 4, and I need to ask myself, how do I get the closest that I can to this by multiplying? And I think 100 is a very easy way for us to get there. The students are able to multiply times 100. So I'm going to go ahead and I'm going to write 100 up top. 4, well, you can even put a little time sign there. 4 times 100 is 400. So we go ahead and subtract. We end up with 3 and 3 and 3. So 337. We're then going to add on another box to our original, and we're going to bring that guy up, 337. I look at my list over here and I see, okay, I know I can't do 100 again because that would be 400. It's too large. And I know I can't definitely do 200, but maybe I could do 50 here. 4 times 50. That's 200, so that would work. So I bring my 50 here and I write my 200 down. So I bring that, bring it down, 7, 3, 1. So I'm at 137. Now I look at my 4 and I look at my 137 and I'm like, okay, how could I get that as close to it as I possibly can? And again, I wrote down my facts over here. So I see 4 times 20 equals 80. I know it's cut off, but that's 80. That's going to get us fairly close there. So we can go ahead and do 20. That's 80. We subtract. We have 7. We have to carry a little bit, so we're going to go ahead. This is going to become a 0. This is a, it's very hard to write here for you guys to see, 13. So we have 8, 9, 10, 11, 12, 13. So that's 57. I look at my list again and I say, how could I get close? Well, 4 times 20 is too high. 4 times 10 would be 40. 4 times 11 would be 44. 4 times 12 would be 48. We know our multiplication facts, so let's do a 12. So we can go ahead, we'll bring that guy up, 57. A 12 makes that 48. Again, we have to carry, so that's 0 there. Or, I'm sorry, it's 4, which is going to make that a 0. And then this is going to be 17. So we have 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Utilizing your fingers to do your counting is perfectly fine. So we end up with 9. Then I look at 4 and I look at 9 and I'm like, okay, one more step. I can do one more. I bring my 9 up. I can do a 2, which is going to give me an 8. And that ends up with a remainder of 1. Final step is to go ahead and add all these together. So 100 plus 50 is 150. 20 plus 12 is 32, but we can just add that other 2 into there, 34, and we get to 184 for our divisors here. So we come up here and we say, okay, the answer is 184. However, I had 1 left over that I can't do anything with, so we have 184 with a remainder of 1, or 184 and 1/4. This is the way students are going to have to represent their division in on the FAST test and in class. So they really do need to know how to do this fraction thing, but they're going to see both, so it's good to be able to do both. So I'm going to have students, they're going to have to recognize and show me both for each problem so that way they understand. But yeah, that is area model division. Yeah, have a great day.